Hi, today I'm going to talk about assignment 1. It is about encryption and decryption. Encryption encrypts a text to some cryptic text, and decryption turns this cryptic text into plain text. So when encryption and decryptions are used, let's say you are trying to send a message to one of your friends, but there are lots of people in between you and your friend, and you don't want those people to know what you're sending to your friend, so you encrypt your message to this cryptic ciphertext and send to your friend. So all the people in between, they also see the cryptic text, but they don't know what they mean. But your friend knows how to decrypt it to plain text, so that he decrypts using the techniques that you already agreed and get your message. Hi, these are the 4 files that we have, and hopefully these files you have downloaded from Dropbox. First 3 files are our concern and your concern too. You need to add codes in these files. Currently these files have empty methods and constructors, and whenever you test this code by running this file, the output you'll get are exceptions because these methods are not implemented. Now once you start adding the codes into these 3 files and then you run the encryption test.java, you'll no longer get exceptions. Okay. So I suggest you to add codes as an incremental basis. So once you add codes into these files, so you run these test file, and in the test file there are codes to run all the 3 files. Now let's say you have added codes to the plaintext.java and you haven't added code to ciphertext and private encryption.java yet. So you will not get any exception from the codes that test plaintext.java, but you will get exception from ciphertext and private encryption. So in the encryption test.java, if you just keep the codes that test plaintext.java and comment the rest of the codes, that will give you an output instead of raising an exception. So that's what I mean by incremental addition of your code. Now let's look at some more detail. So here we have these 3 files. Now what do these files do? Now let's say we have ABC, and ABC is just a text, and this text is fed to a box called encryption. And then once you fed this text to encryption, this box will give you output, and this output is another text, DEF. Now DEF has been generated from ABC by shifting each character by 3 places in the alphabet, so ABC becomes DEF. Now in this assignment we would say ABC is the plain text and is represented by plaintext.java, and then DEF is basically a shifting of ABC, which is basically a hiding of the plain text, and then this one is represented by ciphertext.java, and in between we have this box encryption, and this box is basically doing something, is encrypting the plain text to ciphertext. So this box is performs accordingly to the encryption shift method that is inside the private encryption.java. And now we did the encryption, we can go backward. So from ciphertext we can go to plain text. So here we have the ciphertext DEF, and then if you fed this ciphertext to this box, it will give you plain text. So you're basically going from ciphertext and to the plain text. So what does it do? DEF was a shift by 3 places on the right, and this box will do the opposite, will do the shift by 3 places on the left. So this is a decryption, and these box will perform accordingly to the decryption shift method that is inside private encryption.java. In private encryption.java, there are 2 more methods. One is encrypt pass. It also encrypts the plain text to ciphertext, but using a different method than shifting. You need to pass a password, and the encryption will be performed based on the password. And decrypt pass is basically decrypts a ciphertext that was encrypted using a password, and then it gives you back the plain text. So there are 2 more methods, and I will probably not go into the details of these 2 methods, but encrypt shift and encrypt pass are 2 different ways of encrypting a plain text to ciphertext. This is the plaintext class that has a variable called message and 2 more methods. One is to set message and another is to get the content of the message. Now this is an abstract definition, so I want you to always remember this is abstract. It means whenever you run this code, it doesn't have an existence in the memory. It doesn't create any instant in the memory. It's just an abstract definition. But once you do this stuff, so here's a line that I'm executing. This line creates an object of the class plain text, and then once you create or execute this instruction, it creates an instance in the memory. So it means that it is creating an object, and this object will have an existence in the memory. By an existence, I mean the variable message will be allocated space in the memory, and it will be assigned to this value. Shifts are syncing, and it will also contain the definition set message and get message. Here we have the same instruction from the previous slide. This line is creating the object, and once you execute the line, it will give you this object in the memory. Also note that the value of the message is shifts are syncing. Now I'm adding a new instruction, which is this. So in this instruction, I am calling the set message method, and I'm sending a string as an argument. What will happen? It will change the content of the message variable from shifts are syncing to Mayday, and you can see the effect here. Next, I am adding another instruction where, if you can notice, I am calling the get message method, and get message method returns you the value of the message variable. Now whatever it is, it will be returned here, and printLine method will print that content. So we have done a change to the message variable, and then whatever is changed, we are printing it back to the console. Now as you can see, we are creating 2 objects. One is ptxt0, another is ptxt1, and these are 2 different objects. Although they are from the same class, they are 2 different instances in the memory. So this one is the first instance, and this one is the second instance, and then they don't touch each other. They are separate, they have separate memory spaces, they have separate space for their message variable. So if you change the message variable in one instance, it doesn't touch the other instance. And this is the way you can create many objects of the same class, and there will be different memory space for each of them. Now this is the ciphertext class, and in the ciphertext class we have a string buffer variable called ctxt, and then we also have a toString method. So this is a really simple class. And then in this line I'm creating an object of the class and sending any text as an argument, and this any text will be assigned to the variable ctxt. So after executing this line, I'll come here and get the object acipher, and acipher is a memory space which will have any text in its message variable, and it will also include the definition of toString. In the private encryption class, we have two variables. One is shift key and one is password. Both are used for encryption. So if you're encrypting the plain text based on shift key, this shift key value will be used. If you're encrypting the plain text based on password, the password variable's value will be used. Now we also have 6 methods. First 2 methods are basically if you want to change the value of the shift key or if you want to change the value of the password. And the last 4 methods are for encryption and decryption. So these two methods, first one encrypts the plain text based on shift key, and this one does the opposite. This one encrypts the plain text based on password, and this one does the opposite. Now here once again we are creating an object of the class plain text, and this one will give you an instance in the memory, and this instance is the object which will have shifts are syncing in its message variable. And then what I am trying to do here, I'm creating an object of private encryption, and I'm giving the name scheme1, and I'm also sending 3 as an argument. Now if you notice, in private encryption there are many constructors, and one of the constructor accepts an integer value as an argument and assigns that integer value into the shift key. Okay. Since this constructor only assigns shift key, the other variable, which is password, will be assigned with a random text. Okay. You don't have to pass this value as an argument to the constructor. So this password will be assigned as a random text, and whatever is sent as an argument will be assigned to the shift key. And now these are the definitions. I am adding one more instruction here, which is this one, and in this instruction I am calling the encrypt shift method of the scheme1 object, and this is my scheme1 object, and I'm calling this encrypt shift method, and I'm also sending an argument ptxt0. So if you remember ptxt0, it is basically this object which is plain text. So I'm sending it, and an encrypt shift method will do something with this plain text. Now this is the definition of encrypt shift. I have made some comments inside which are not there in the original code, but these comments will explain what this method is supposed to do. Now let's zoom in a little bit and see what you are supposed to do in this method. So this is the method and this is the argument. So whatever you send here will be stored in the variable p. So I am sending ptxt0, and P's txt0 will be stored in the variable P, and P will be its new name. So in this method I will refer ptxt0 as P. Now if you remember, the message variables of ptxt0 or P is containing the value shifts are syncing. Now what you're supposed to do, you need to shift each character of this string by some number of places to the right. And how many places is dependent on the value of the shift key value. So let's assume that shift key is 3. So this is the new string that you get after shifting each character to the right. Okay, so you add codes to do that, and then the next thing you need to do, create an object of class ciphertext and send the new string as an argument to the constructor. Okay, constructor will assign this new string to ctxt variable of ciphertext. This is how you do it. So in this line, if you remember, this is our ciphertext class, and this is my object name, new class name, and then I am sending new string as an argument. So this is what will create an instance of ciphertext in the memory, and that ciphertext object will contain new string as a value of its ctxt variable. And now you have to return the ciphertext object. So this method will return a ciphertext or a cipher as its return value. Now as we saw, encrypt_shift returns a ciphertext object, so you need to store that. So I'm adding this instruction, ciphertext and cipher. This is basically a variable name which could be anything, and whatever is returned from here, from this part, will be stored in this variable. In the source code, what the instructor has done, he has assigned this variable in this manner. So he is basically creating a new ciphertext object here, and the argument would be the return value of the encrypt_shift method. So if you go back to the code where you can find ciphertext.java, you'll see there is a constructor. That constructor accepts a ciphertext object as an argument, and from that object it initializes the variables of the a ciphertext class and create a new instance. So you can do both. You can follow this approach, or since you already have a ciphertext object, you can directly assign it to a variable. Both schemes are fine. Now in the encrypt_shift method, we send plain txt 0, which was an object of plain text class, and it gave us a ciphertext object. You can call the decrypt_shift method, and you have to send your ciphertext object, and it will decrypt or shift the characters to the left according to the value of the shift key, and it will give you a plain text object back. Similarly, if you do the encryption based on a string, which is password, to encrypt you call this method, to decrypt you call this method. So this is basically the private encryption.java class and all the functionalities of it. Now once you add code, you can run the test file, which is encryption test.java, and then depending on how much contribution you have, if you have all the codes added, then it wouldn't give you any exception. But if you have some code added for those parts, you'll probably get output, but for the other parts you will get exceptions.